there is that bias
Mm-hmm.
variance that you can expect. Some of these models maybe the numeric output you can use the average of the or you can do a hard coding.
Okay, great. Anything else?
Last thing it was like there are the two conflicting kind of properties. So it's hard to have that you have to optimize and
Yep, absolutely. Good. Thank you. Folks online, anyone who would like to add on what you understood so far? First of all, if you're back, let me know if you're back. Hardly anybody has confirmed. Or are
Yes,
we
sir.
early?
I'm back.
Huh? Okay. Kaushik. Okay, Kaushik has confirmed back. Okay. Others? Sorry, I think it was Chirag only. Or was it Kaushik?
Sir, Adityan has confirmed.
Okay. Aditya and
That's all for now. I have texted in the group. They'll be joining.
okay. Yeah, Pranesh, you want to add on anything else, or I mean something which is not clear while we are waiting for others?
from the previous class. Is it good, bad, or like it's over?
It's over prediction, but there might be some error as well in the code. I mean, normally what happens is if you're doing changes on the fly, sometimes something gets. So it's always good to restart the kernel, run one more time, and if that doesn't fix, then take a look. What could be the underlying drivers? Yeah, Pranesh. Sorry. It is definitely worth. I mean, particularly for bigger data and more complex data, you will find that there's a whole lot of value in doing that. Yep. Hmm. Now it's more clear to you? Okay, cool. Anything which is not clear in the ensemble model? Or is it? Okay, fair enough. Folks online, are you back? Shall we start with the next discussion point? Amarnath, Nidhi, Kaushik, Guru. Who else? Yeah,
Yeah, I'm back.
Nidhi, thank you for confirmation. Others? Hmm.
Yes, sir, I am back.
Okay, Guru is also back. Thank you.
Yes, sir, back, sir.
Amarnath is back as well. Okay, great. So I think we have pretty much everyone, right? So we're just talking about were there any questions on the ensemble model from anyone? If you have any doubts, happy to clarify that before I go in the demo part. Anyone who would like to summarize their learning so far online? What you understood from ensemble in your own words, whatever you understood. I mean, I understand that not everything might have been very clear to you, but whatever you have understood, if you'd like to talk about that.
Sir, actually, decision tree is like the drawback of decision tree is overfitting, as you understood. So the more and more we try to accurate the model, it will lead to overfitting. And to
Yeah.
overcome that, we introduce ensemble, in which instead of using one decision tree, we use a forest, or I mean a number of multiple decision trees to come to a decision or conclusion about our
Yeah.
target variable.
Absolutely. Yeah. Thank you, Manath. Anything else you'd like to add on?
So here we try to reduce the variance and bias
Mm-hmm.
using this ensemble model.
Mm-hmm.
And there are like three categories: bagging, boosting, and one minute stacking.
Mm-hmm.
So most of the time we go for the boosting, which provide like the one learner can provide all the inputs to the other learner. So that
Yeah.
way the result boost enhances.
Absolutely. Yep. Thank you, Nidhi. Guru Prakash, yeah, go ahead. You're saying something?
No, sir, sorry.
Okay, fair enough. So then let's go ahead and look at some hands-on demo, right? And what we'll be doing, and I'll show you everything in more details when we do the H2O. But just to level set the expectation one more time. So we spoke about bagging, and I'm just trying to make sure that you understand. So here, each of the trees are working independently and they will give us their vote. And based on that, we have the final outcome defined. So this is the concept of the bagging, right? Boosting, on the other hand, let's say we are looking at boosting, is we have the different models, and these models could be anything. These models could be linear regression, could be logistic regression, could be KNN, could be a decision tree, could be neural network. These models could be any of these models, right? So boosting, what happens is they're not working independently. They are given the inputs, right? So based on that, the first model will do certain classification. It will pass on a signal that I am finding, certain observation, let's say observation 1, 10, and 15 to be misclassified for me, right? So now this guy will say, okay, 1 is more important for me, 10 is more important for me, 15 is more important for me, and so on and so forth. So they work in conjunction with each other. They talk to each other, right? Stacking is completely different. Stacking basically is a model of model, right? So you can imagine that I have model 1, model 2, model 3, model 4, and these models could be ensemble models themselves, right? So for example, this could be a model of the trees, but what happens is the output from this model becomes an input to the next model, along with the X. So all the X's that we are passing on to this model, they will continue to have that. Then on top of that, let's say this model says 1010, so 1010 will be fed to the model 2, and then so on and so forth. So they're the stacked models, right? So they're stacked on top of each other and they become actually better over a period of time. That's the concept of stacking. We'll talk about random forest very, very quickly, and we'll do the application on the Titanic data set, right? Let me know if there's a question. So what we're going to do is just work with your Titanic data. The only thing you will add is my estimators. Add this one, please, and let me know once you've done it. So I'm just going to zoom in so that you know what line I'm highlighting. Everything you have done in Titanic decision tree, just insert one more code or one more section, call it random forest, and let's work on that, right? The only thing we are adding over here is this one. And this means basically we're going to try 10 trees, 100 trees, 1,000 trees. You can try in between also, 500 trees, for example. Let's see what comes out best. So let me know once you're done on Titanic, and then I'll give you a brand new data that you're going to work on. Let me know once you're done. Ganesh, question? Let me know if there is a doubt. So basically what we're doing is we're just defining the hyperparameters. One more hyperparameter that we're adding on, my estimators, which is the number of trees. So a forest with 10 trees, a forest with 100 trees, with 1,000 trees. And we want to see how that looks. People who are done with that, then you're gonna import this object from sklearn.ensemble import random forest classifier. You will import random forest classifier instead of the decision tree classifier, random forest classifier. Are we done? Not yet.
So this is PCA. I mean, this is principal component analysis, or we are doing random forest?
No, 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 no. PCA will be separate. I'm working on the same data that I'm gonna give you a walkthrough later on. But right now we're just gonna do a plain vanilla random forest without PCA.
Oh, okay, okay.
Amit, done? Or still typing? Done? So we are adding this line, my estimators, and then from sklearn.ensemble import random forest classifier. Then we're gonna create an instant, which is the forest, or you can call whatever you want to call it, random forest classifier. Class weight is balanced. Random state, you can choose any random state that you would like to have. Okay, once you've done it, then the grid search will remain the same. Forget about all of these things. Then this is what you're actually gonna put. Exactly the same as what you've done last time, right? But the only difference over here is you have one more dictionary item, and you can copy paste your decision tree model fitting code. The only difference over here that we're making, I think the CV is fourfold now. I mean, you can do the fivefold, is adding on this, which is the n estimators is equal to my estimators, because I'm looking at a random forest. That's the only difference. Hmm? Scorer, okay, scorer is over here, sorry. I think I'm defining over here. Scorer is sklearn metrics, make scorer, and I'm saying recall underscore score, and average is weighted average. So I want to look at the recall of both 0 and 1 in a weighted fashion.
So this we need to apply on Titanic or Boston.
This is on Titanic, I believe.
Okay.
I'll just check. Oh, actually, it's neither Titanic nor Boston. This data is different, but you will apply on Titanic. And what we are doing over here is the scorer is this one. It's a brand new data, actually. Shall we move forward? Sure, sir. You got the scorer. Anyone else? If you're not clear about the scorer, I'll just put the code over here. Basically, what you have to do is you have to define what you will optimize for, and then you are typing this code, which is exactly similar to what you've done for the Titanic decision tree. Only two differences over here is my estimator is not decision tree; it's a forest now that we have defined. Scoring, I'm doing using scorer, which is basically trying to optimize for the recall, right? Then we are gonna have this new term added over here, this new parameter called n estimators, and that's pretty much it. Everything else remains the same. And then you can fit your model and let me know whether you found the performance to be getting better or not. Sunny, Shilsa, Amit, let me know if you are able to submit and it's running for you. If anyone needs help in understanding something, we'll be more than happy to do it. So, and in the meantime, what I can do is I can look at the old Titanic data and show you the precision and recall comparison. So this is from the random forest, optimized random forest that is, right? So I'll just put it there. and it may or may not look better, right? So there is no guarantee that random forest will always be better than the decision tree. If the data is simple enough for a decision tree to understand, then that may be the case, right? So,
Sir, can you show your hyperparameters once again?
okay, sure.
Yeah. No, sir, the above where you are defining it, that part. I want to go with the same data. So
I'll just keep it there in the chat window for your convenience.
yes, please. Thank you.
So the confusion matrix for random forest looks like this, and I'm just gonna graph from the decision tree as well. And this is what, without threshold optimization, the confusion matrix for a decision tree looked like, right? So let's go and put them side by side. The top one is the decision tree. Sorry, let's do the right and left, right? So that you can look at both together while your code is running. Right, so exactly the same data. So this is the decision tree, 0.8, 0.74, 0.86, 0.85. So precision looks better for both classes. Recall 0.88, 0.61, recall 0.91, 0.72, right? So you can see pretty much all the metrics have become better in the random forest compared to a decision tree. Exactly the same data, no changes at all. Instead of just a decision tree, I put a random forest. So you can see they are able to help us reduce the error in the model and improve all the metrics simultaneously, right? Pretty much every number looks better over here compared to what we had earlier on. And since F score is nothing but the harmonic mean, even that looks better. So that's what I'm expecting, but let's see whether you get the better performance or not in the random forest. So if I just look at the recall, for example, I'm looking at 0.72 minus 0.61, that many or 11 bips improvement. So this divided by the original performance, which is 0.61 times 100, which is almost 18% improvement in the recall, which is quite significant just by trying a different technique, not even doing any other feature engineering, anything of that nature, just different technique. Okay, so if you're done with that, I will ask you to start working on the next data. I mean, once you're done with that, I'll just talk about where this data is going to be. And this will be your graded assignment, right? So this is what you will submit today, a brand new data. And in fact, what I'm going to do is I will send this entire code to you folks so that you don't have to necessarily worry about typing it. I don't know whether you've worked on this data earlier. Does anyone remember working on the wine data? Once you're done with your Titanic one, let me know. I'll walk you through what this data is. And then using the same data, we're going to do a principal component analysis, PCA, as well.
The Titanic data is from CVOL, no? SNS.Titanic, same data.
Yeah, same data. So once you confirm that you are able to get the output on the Titanic, then we will go on to this new data, which will be submitted as your graded assignment.
Sir, what is make score in a scalar?
That is just for your, I think it's here only, right? So I'll just, that is more to really figure out how you want to score that, right? Um, in this case, we are saying score based on the, hold on, recall, and that too weighted average recall. Weighted average meaning both 0 and 1 I'm interested in. So it was over here. Here, scorer.
Okay, I got it now.
Done?
Yes, sir.
It's running. Okay. How many of you have got the output from the random forest on Titanic? Anyone? Or still learning? Right? Still running. Yeah, it may take time because it's like, complex model. So, I mean, I fired up this query right when I actually came in this morning, still going through for the MNIST data. But I will not give you that as a assignment because it's too much. That's why I'm actually looking at the wine data. That's easier for you to understand.
Sir, I'm getting that sklearn has no attribute make underscore score.
Okay. sklearn metrics dot make scorer.
Okay, scorer. Let me try now. Okay, scorer. It works
Scorer.
now.
Yeah. Yeah.
Yeah.
Okay. Cool.
And sir, are we using random forest classifier?
We are using random forest classifier over here. You can see class weight is balanced to account
Now
for the imbalanced data.
I have, sir, a different error now. It says that invalid parameter estimators.
So there might be a typo. So for example, my estimators is the name of the object that we're defining, but this will be n underscore estimator.
Okay, I got it. I got the problem.
Yeah.
It's estimators actually.
N underscore estimators, number of estimators, basically the number
Yes.
of trees you want to have.
Yeah, that was the problem. I got it.
So in this case, I think I was doing, no, this is post PCA, but I think pre PCA, let's see how much time it took me. Around 479 seconds it took me to get the output on this. And then after PCA, the hope was that it will be lower, but I don't know whether that was the case or not. 445 seconds, so it was somewhat lower.
For me, grid search is still working. So till now, no output.
It would be showing that it's running, right?
Yes.
Yeah, it takes some time. So 7 to 8 minutes is what you should look at a bare minimum. Maybe 10 minutes, depending on the speed. And that too, I believe my data is slightly smaller over here. So Titanic is maybe about the same size actually. So it should be roughly the same time, around 10 minutes, not more than that. Actually, it took 586 seconds for the Titanic. I was looking at the other data. So that's what, 9+ minutes, 10 minutes.
And then you are looking for the best parameters, what we get, right?
That's correct. Sorry, Amit, say it again. Dot metrics dot make underscore scorer, I think. You got it? Anyone has the output now or still running?
Format is still running, sir.
Okay,
Running on Google Colab.
all right. If it is more than 10 minutes, let me know. I don't know whether you made certain mistakes or too many parameters. Should not take more than 10 minutes.
Sir, a question.
Yeah.
Sir, whenever we fit a model with grid search, and then we built a new model with the best parameters. So
Mhm.
between these two steps, I mean, getting the trained model and before building a new model with the best parameters, if we try to do a prediction, Then on which parameters it does that?
You don't have to build a new model. I mean, we did it because we wanted to visualize the decision tree, right? Otherwise, you can directly move on to predict and it will leverage the best parameters. So for example, let's say you have created an object called as grid, right? And that has automatically given you the best parameters. So you just do the, like, what we've done over here. Like I'll just show you, where you just directly go and make the prediction based on that. I'm just gonna scroll down to the section right over here. So we say grid underscore RF is the my optimized grid random forest, right? I mean the grid search random forest. I'm directly using predict. So you don't have to pass on any parameters. It will take the best parameters for you.
Okay, I got it, sir. Thank you.
Yeah.
I was
That was
thinking
just for visualization. Yeah.
maybe I was thinking it is taking some random last iterations
No, no,
parameter.
no, 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 no. It will take the best ones.
Okay, thank you.
For me, that grid is still running, but what I saw using the plain decision tree, the accuracy was 76%,
Mhm.
but random forest with the plain thing giving 80% accuracy.
Okay, so it has automatically improved with the random forest without
Yeah,
the
without how
optimization.
hyperparameter. Yeah, yeah.
Yeah. Yeah, and it depends really on your system as well. I mean, how much time it's going to take and all of that, right? So there's no telling. But yeah, you can keep an eye. I mean, if it is taking too much time, just try to cut down the number of parameters and rerun. So just try to see whether you can strip down some of these numbers to something more manageable and then rerun. Anyone who has got the output, by the way, or still running? Google Colab folks may get it sooner. I mean, if the bandwidth is not a problem.
So grid is completed on Google Colab.
Okay, awesome.
That
Good
criteria
to know
is
that.
coming entropy, maximum depth 10, sample is 2, split 10, estimated 100.
Okay. And you see the performance better than the decision tree, Nidhi?
I'll just go on with the further code. I just wanted to know like if others are waiting.
Okay. Huh? 1,000. Oh, okay. That's quite a steep jump actually from 10 to 1,000. I mean, because I got 10. But let's see. Just compare your model performance to the decision tree and see whether it looks better.
So, sir, for decision tree, without using any hyperparameter optimization, we got recall 0.55, and here I got 0.71. Sorry,
Point,
0.61. 0.61.
point,
Better actually.
0.61. Okay, got
Yeah.
it. Yeah, that's good.
Without any optimization.
Yeah. So you can see like, the ensemble models generally outperform the more simple plain vanilla models like a decision tree, logistic regression, others. Awesome. Let's go ahead and do the optimization as well.
Right.
Anyone who is stuck getting some error, do let me know. Not able to run your code.
I got an answer.
Mm-hmm.
And criteria entropy, max depth 5, leaf
Okay.
2, samples 5, estimated 100.
100 estimators. Okay, fair enough.
But my max depth is just half what Nidhi got.
Got it. Got it. No, it can vary. I think it just depends on because it's a random forest, right? So there will be certain things, but more or less the numbers of the precision recall, they should look comparable. They should not vary a whole lot.
My recall is 0.98
Okay.
and for class 0, for class 1 it is 0.58, F1 is for 0.89 and 0.72. It's promising.
Got it.
And weighted average is 0.83. So it's awesome.
Yep. Awesome. That's really good to know. For the folks who are done, you can move on to the assignment that we're gonna submit in the class, right? And I've already put the code that. Just a second, yeah. I'll be back. I mean, we can do. Folks, have you met Funny? Funny. Have you interacted with him earlier? So Funny is sort of like, I'll just put on this also so that people who are there on the phone can also hear me. So folks, we have Funny who is from the very beginning with Race, right, and has been helping in execution of a lot of different programs. I believe you're still doing those morning sessions, right? Doubt clearing sessions he does in the morning. So the fast track analytics, right? So if you have any requirements, and he refreshes on some of the concepts that we are learning over here. So I'll let him talk and educate more people. You can speak here. So.
Hello all, yes, as RP said, like my name is Pani and I'm here with Race from past 5 years, the moment Race team started. And I do PhD with Shinu and JVS, so they both are my guides and mentors. So that's what basically I do take the fast track analytics because I do work I do work as a senior data science manager in Sunrise. So here I associate with campus on every Saturday I do come here. And I do lead a module called Fast Track Analytics, and it would be shared with you shortly if you are applicable for that batch. And mostly your mock interviews would be taken care by me, and your capstones, reviewals, and all whenever it is required, I would be coming in. So the introduction reason is that if you need any help as such, anything that if you feel like something that has to be corrected, something you need a help of any other mentors and all, or anything from my side with respect to your learnings, you can reach me anytime. All right.
Yeah.
I think my number is already added in your WhatsApp
Funny
group.
will be there in your group.
In your
I mean, all
group.
the groups have
So
Funny.
yeah, just call me for anything, and if it is possible, then we will address it accordingly. Right? Just feel free to talk to me whenever it is required. The reason for asking RP to introduce me because we never spoke to each other, right? So don't think that newness here. So now we are known to each other. So anything if you want, you can call me. Right? Thank you so much. Thank you, RP.
Thank you. Take care. Okay, folks, if you're done, then you can move on to the next phase, which is building the end-to-end decision tree and random forest on a brand new data. This will be what we'll be submitting. And I'll just give you a view of what this data is. So I've already shared, I believe, the code with you. So you can copy paste that. And what this code or what this data has is basically following, right? I'm just gonna talk to you about that. So this is coming in from the UCI Machine Learning Library, University of California at Irvine. There are many, many different parameters like alcohol, malic acid, ash, and so on and so forth, right? So we have these parameters. And then ultimately we have something called as a class label, right? Which is the quality of the wine. And you will see that there are 59 wines of label 1, 71 wines of label 2, 48 wines of label 3. So what we want to do is build a decision tree, optimized or hyperparameter optimized decision tree, and a random forest to do the prediction of the wine classes. And this is your first multinomial classification model as well, right? So what is multinomial? I'll just show you very quickly. So instead of looking at the true and false or yes and no, you will see the classes or the confusion matrix. I think I'm directly running a random forest, which is fine, but you can do a decision tree as well. So you'll see this sort of confusion matrix, right? Your precision recall will be defined for class 1, class 2, and class 3, right? And you'll be looking at a confusion matrix, which is going to look like this. Prediction 1, prediction 2, prediction 3, actual 1, 2, 3. And what we'll be looking at down the road is when we do the PCA on the same data. And I haven't spoken about the PCA. We'll see whether we can get to do it today or next time. We will rebuild the model and we'll see, what exactly the PCA has done for us in terms of the confusion matrix. So right now the ask is you can take maybe next 1 hour or so to build a decision tree and random forest on this data. And let us know how your confusion matrix looks like in this case. That's the ask, right? Is that clear?
From where will I
Decision
see
tree
the
and random forest, yeah. Yeah. Decision tree and random forest very quickly should be just pointing to the new data over here, not necessarily too much customization. You have to make some changes over here. So normally you have only 2 parameters over here. Now you have to insert a third one as well, right? And then generate the confusion matrix, and then we'll begin the discussion on the PCA if time permits. So very quickly, go ahead and give it a try and let me know what you find out. Eh? 3 classes are there. So when you look at the data, do the description of the data, you'll see 3 classes are there. Class 1 wine, class 2 wine, class 3 wine. Right? So we're trying to do a multinomial classification now, which is not a binomial or binary, but multinomial. So we have 3 classes, and we would like to understand how those wines are laid out, which are the top parameters, and so on and so forth.
Sir, is it for practice or is it like an assignment?
This will be a graded assignment.
Or this is a graded assignment?
Yeah.
Yes, sir, 20 marks, right?
Yeah. difficult to select,
Hello.
Yeah, Nidhi.
The data file coming as a notepad.
Hmm?
Data file, when I download it, it is coming as notepad, not the CSV or Excel.
Nidhi, you can directly put the link under read under.
In the Google Colab.
Yeah, you can directly put the link. It will work.
Yeah. This link right over here, you can put, I believe you can see my screen, right, Nidhi?
Yeah.
Yeah, so
Okay,
you can
let me
put
try.
this link. Yeah. And then you'll be able to pull in. The only thing there is that it doesn't have the column name. So that's why I actually specified them separately. And that is the code I've sent you on the chat window. So you can just directly copy paste the same code over there, and then you'll be able to import that data. And do some descriptive statistics as well, like you do for any of the new data that you're working on, just to really understand, right? And it'll be good to see some of the insights also, what you understood from the data before you do the modeling.
Okay, got it. Yeah, I can read the data now.
Okay.
Sir, they just have to upload the IPyNB file, Jupyter notebook, right?
HTML file and the insights from it as well. So as of now, they can just confirm the code is working. Later part, they can work and then submit by tomorrow. The insights and the takeaways and all the PPT related stuff that we've been doing, that we can submit by tomorrow. But I just want to make sure that they are able to fit the model on the brand new data and then able to interpret that. That is what we are looking at. But actual submission may take tomorrow.
Okay.
Same as, and you can have the same direction, Chirag, as we've done for the previous assignment. So
Yeah.
like descriptive statistics, whether we should use this model, why not, right? What are the main takeaways? What are the key features? So on and so forth.
Okay, sir.
So we need to do decision tree and random forest both on this particular data.
That's correct. Yeah.
Okay.
Yeah. Well, we can take a tea break, yeah. Let's do that.
Hello.
Yeah, Nidhi.
So the class label is our dependent variable here,
Class label is the dependent variable. That's correct.
and it has 3 values, so not a binary.
Yeah, that's correct. That's what I was explaining, that you will get a confusion matrix which would look like this right over here.
So do
And
I need to do anything explicitly for like since there are 3 things, or I can just go on with the coding?
no, for this one, for confusion matrix, nothing else needed. For plotting the confusion matrix, you'll have to do adding one more, right? So far you've been doing the prediction 1, prediction 2, actual 1, actual 2. You have to add the third element, which is a prediction 3 and actual 3.
Okay.
Nothing
got
else
It. Yeah, got it. Yeah, thanks.
in the same list. We can take a tea break, folks. Who wants to grab the tree? नहीं यार He was there. You found something?
Hello, sir.
Yeah, tell me.
Yeah, sir, I have a very small doubt. Can I share my
Please.
screen?
Yeah, go ahead.
Yeah.
Definitely share your screen.
I have shared it now.
Hold on just a second. Yeah.
Sir, I just run the random forest one and it's giving me everywhere 111. And other thing is, I don't know I'm writing it correctly or not, but I'm doing the test and the prediction. So here the X labels, is it correct? I'm not sure.
Something looks fishy actually. Go up. Let's see what you have done. Let's go slightly higher.
Yeah, but sir, before that, please tell me, sir, here in the confusion matrix, I'm putting as y test first, right? So this will be on the x-axis. So this should be the actuals, right?
This is the actual. Y test is actual. Predicted
So
is your predicted values.
yeah, so then here on this axis, I should be writing as actuals, right? Because here I have written y test actuals. So x labels would be the actuals, right? Actual 1, 2, 3 here.
No, it depends on go up to your confusion matrix higher, like the actual output. Yeah, there you go. So the actual number of classes for 1 are 12, for 2 are 11, for 3 are 13. Go down now. So I think it's, in this case, it's hard to tell. But I mean, you would normally be able to figure out whether you put that in the correct way or not. But I believe you are correct. I mean, there's nothing wrong. I'll just confirm. So prediction is on the x-axis, and the predicted prediction is on the x-axis, and the actual is on the y-axis, right? I'll share my screen very quickly, and I'll create that doubt, and then we can go and figure out what is happening in your system, right, or your codes.
Yeah,
Is
and
it,
here it's
is it DT?
Sorry?
Is it DT? Decision tree?
no, it's random forest.
Okay. Decision tree also the data is coming similar. I mean, the values are not
Okay,
exactly similar, which is on your screen.
Yeah.
Sir,
So
I
you can see.
start from top.
No, I mean, I'm sharing my screen just to really clear your doubt on the confusion matrix first. Can you see my screen?
Yes, I can see it.
Right. So in this case, you can see I have 20 in the second class, first, I mean, 10 in the first class and 6 in the third class, right? So now let's add up. So you can see actual is on this axis, right? So 20 in the second class, 10 in the first class and 6 in the third class. If I look at the from the prediction axis, you can see there is, something which is wrong, or I mean, you can see, how they have been laid out in terms of the misclassification that we're looking at. But you're right. So prediction will be on the x-axis and actual will be on the y-axis, which is correct on your screen.
Okay.
And this is actual. This is predicted. So don't get confused with respect to the plotting of the matplotlib, because what you're saying is confusion matrix will take actual and predicted, and then heat map you're generating from this confusion matrix, and it lays out like this, like we saw earlier on, and then you're just doing the color coding and the labeling of the axes.
Yeah, so the order in which we write and the way it presents is different actually. So
Yeah,
on
that's
in
correct.
order we are writing as the actual first, and while on the X it's prediction first.
That's correct. That's correct. So it's always going to lay out
I
the
guess,
predicted on this
I guess
and
it's
actual.
with
Sorry.
X and Y.
Huh?
It is in the order of X and Y. So it is
No.
correct.
Yeah, no, but he's talking about this, like, I mean, the actual we're passing on first. So his thought is that if you're passing on X, I mean, actual as the first one, then actual should be over here, which is the plotting. But the confusion matrix plots that in this way: prediction on the x-axis, actual on the y-axis.
Yeah. Okay, so then I am doing the right thing, but the only thing is now this I'm getting is 100% accurate 111.
Just rerun that. I mean, I am also getting very close to 100%, so I'm not surprised. Because if you look at my confusion matrix, the only thing that is getting classified is this observation. Everything else is zero in my case also.
Okay. So, sir, I will
Huh?
share my screen. I will share my
Srivalsa
screen now.
also is getting 100% actually, right? 100%? Yeah, so 100% is close enough. Yeah, sorry, go ahead.
Yeah, I will share my screen. It's hardly 3 lines of code actually, so nothing more than that.
Yeah.
I think you can see that.
That's correct. I can see it.
So this one I took from what you pasted there in the chat. So import pandas numpy, create a data frame, and then assign the columns to it, head of it, then get X, and then get Y. And after that, I was doing some info describe and null, so there was no nulls actually. So nothing more here. Then here simply split it on 20%. So 80-20 ratio. X train test, Y train test. Then run a forest classifier. Mean squared error classification report. Create a classifier, fit it, score it, and then predict. MSE RMSE is okay, simply I did that, but you can ignore it. And then classification report, and then confusion matrix, and that's it.
Yep.
And it's giving me everything.
Looks good. Just rerun one time, but I think 100% might be correct. Not a problem.
Okay, I'm rerunning it again from here.
Okay.
97, 98, 99. This will be 100. And 101, correct. This is 102. And again 111.
Yeah. Okay, that's fine. I think it's just the data is very simple for the random forest to understand. This you've done the cross validation and everything, right?
No, it's simply random forest, no grid, no cross validation, nothing. Only train test is split and then just fit and predict. It's simple.
Right. Yeah. So straightforward, plain vanilla random forest is what you have.
Yeah. Yeah. And with this everything, precision recall, F1 score, all are one.
So this might be overfitting your data a little bit just by looking at this, right? So that's why, I mean, sometimes it's helpful that you do the cross validation as well, just to really confirm, right? So like we've done earlier on, just follow the same path of doing the cross validation and trying to optimize the parameters and see whether that is again 100%.
Okay.
Yeah, because you're doing the train and test split, right? So there is a possibility that it might be overfitting, but if you do the cross validation, then you're gonna have a more solid model.
Okay. Thank you.
Yep. Anyone else? Any questions, thoughts, people from anyone? Okay, so you can take this as a homework, people. What I'm going to do is now is in interest of time, you can do the homework and you can submit later on. That's fine. I will open a brand new notebook for you, which talks about the library called as H2O, right? And we'll spend some time talking about that, which will help you build many different versions of the model in one go, right? And I would recommend you to do this in the Google Colab because I'm not sure whether Jupyter notebook will be able to handle that. And what we're going to do is we will look into this library first. So I'll put a link over here, and if you can take a look very quickly and let me know in the next 5 to 10 minutes whether you've done it. So just go to h2o.ai and glance through some of the things over there. And we will look at one of the packages which is from there. And I'll show you how to build many different models using the AutoML part, right? But you can go over here and look at platform, right? And look at what these platforms are. And we will kick off the conversation in about 5 minutes time, around 4 o'clock, once you've glanced through it. Okay, my bad. Now you can see it, right? H2O.ai. Just look through the platform, spend some time. I'm going to demo one of the packages, which is a free package in Python, and how it works. And then I'll give it to you to work on it as well. So we'll start discussion at around 4 o'clock on this.
Sir, this multi class multinomial classes. Do you refer any materials to study for easy to understand in your blog or somewhere? I'm getting little distorted data. I mean, the result is not correct. I'm sure. So, any reference?
Amarnath, he is coming back.
Okay.
Yeah, Mannath.
Yeah,
Hi,
sir.
Mannath.
Yeah, sir. Actually, I'm asking like, do you refer any? Do you suggest any reference to study? Because the model I got, I know the data result is incorrect. The matrix, confusion matrix I got, right? So I want to like in this kind of multinomial classes, we want to predict. So, do you any suggest any reference material for study or something like in your blog or somewhere?
Your voice was little bit shaky,
Okay,
but are you
no
saying
problem.
that?
Yeah. I'm just asking some reference for this kind of this problem, particular problem, multinomial classifications. So we have multiple classes to predict.
Yeah. So generally you should try, 3 or 4 different types of models and then see what gives you the best result, right? I mean, that is how we will proceed in most of these cases. But this seems to be a very, very easy data because the size of the data is very less, right? So 170 odd observations. So that's why the random forest is easily able to understand the entire data, right? Even with the cross validation, we are getting a very good number. But you should not ideally expect that I'm gonna see this sort of performance coming in. That rarely happens. This is too good. Yeah.
Yeah, I'm
Are you
good. I'm
good?
getting a different result actually. So I just want to know where I'm wrong. I think I know where it is wrong. So I'd like to share it once, sir. Before you quickly, maybe it will take 1 minute to rectify myself. Just need your input.
Yeah, no problem. Please share your screen. Happy to take a look.
So
You can share your screen and then we can take a look. Yeah.
yeah. This is the confusion matrix. Now I know it is wrong. So I just because I didn't. I think I need to again this class label. Probably I need to get dummies. I think so. Right.
No. Class label is already there in that format.
Okay, but then
So
I'm getting it
yeah,
wrong. But
hold on. Let's go slowly. I mean, I cannot see like that.
right, sir.
Um, so 178.13 and Y is 178. Yeah, that's fine. Line number 11. Let's take a look. 11, 12. You're building the decision tree classifier as of now. Fit this, predicted this. Yeah, okay. Line number 13. Yeah, hold here, please. Okay. Test Y and predicted. So everything is coming in one column only for you, right? Or I mean, one row
Yeah,
here only, or one
yeah.
class
Yes.
basically. And that's where the problem is originating. Only one class is being predicted, right? So there's nothing that is there for the first and the third. And everything that you're predicting is second class also. I mean, because I just saw some of the
Yeah,
numbers there.
yeah.
Okay. Do you mind rerunning the code one more time? I don't know where exactly something has gone wrong. Just run one more time. Let's see if it is there same way.
Yeah.
Just run from the beginning one more time. Run time, and then you can say, yeah, no, just go to the run time and run all. That's okay. Yeah, run all. Uh, go up. Yeah, again, the same thing you're getting actually. Now it has shifted to this one. I think it's the same thing. You're also getting same way? So we are getting extremes actually. So some people are getting really very bad model and others are getting really very good model, right? Um, can you do me the label count in your train data actually very quickly? I'll just share the code with you. If you can do a quick label count, just a second. That will be
Okay.
helpful for me to understand whether there is something wrong with respect to the data that is split, right? So you can just do a quick count like this. I'm going to share and do it for both train data and your test data so that we know that that is correct.
Okay.
So for your train data, I mean, you have to, just do it at the very beginning and then see whether you can run it on the X train and Y train as well to confirm whether we are looking at the right distribution. X train and X test. Or basically the Y train and Y test in this case. What is the size of the labels that you have?
You want to see the shape, sir?
Yeah, I want to see the not shape, but I want to see how many 1, 2s, and 3s you have in your test data and the train data.
Okay.
Like the classes, if you can do the grouping of the classes.
Got you. So what will give me the values for each class?
Yeah, each class, what we are looking at.
Count is it? No, it will give total count, I think. Just checking. Yeah, it is 142, but it's giving this thing. So whether info will give that, I'm just checking.
No, you do values underscore count.
Okay, let's see.
No, values underscore count.
Yeah.
Underscore.
Hmm.
Value underscore count should work actually. Just tab, press tab, check.
Yeah, value count. Yeah. Yeah, values are there, sir. Values are there for each class level. Values are there. And let me check for test Y also.
For the test one, if you can confirm.
Yeah. No, I think something I'm doing wrong. Definitely, I'm not getting it.
That's okay. We'll figure it out. These are the things where you
Okay.
learn something new. So we'll figure it out. No problem.
Okay, sir. Yeah, values are there for each class actually.
It is there, right? Yeah. So that
Hmm.
makes sense. 20, 10, 6, this. Yeah. Go back, please.
No, here you have
So,
different mean sample leaf is 50, but that much data itself is not there. Mean sample split and mean sample leaf.
there you go. There you go. I think that's the problem. These values are very, very big. So that's a good catch. So go with a smaller value. Because your tree is not even splitting. It's not even working. So go with the leaf of maybe 2 and min sample split of 2 as well. Let's see. 2 and 2, both of them. 2 and 2. Because your data is not that big, right?
True.
There.
I didn't realize that.
Yeah. Now let's see. Yeah, now it is there. Perfect. So good catch, Kosik. I think that was a problem.
Very good. Thanks, Kosik. I was thinking I'm doing something wrong actually because since it is multi-class problem, so I was thinking I'm doing wrong. No worries.
No,
Thank
I
you.
mean, yeah, that's where, I mean, if you don't know what parameters you should be having, so just go back to your code, Amarnath, I can tell you. Go back to your original code where you change that. So just go with the plain vanilla decision trees. Just remove anything, min sample,
got
leaf,
you.
and
Yeah.
because
Basically, you are
that is a
saying
safer bet. Don't specify anything until you fine tune it. So just run with that. Let's see what is the performance.
Okay, sir. Thank you. I'll work on the other one, then I'll stop sharing.
Yeah. Oh, fair enough.
So for me, DT is 93.3% and random forest 97 something.
Mm-hmm.
The accuracy metrics, accuracy 97.7.
Okay. So you're not getting the perfect 100% like a lot of other people are getting, right?
No.
Yeah. And it just depends on like how the distribution has come out really and what we have, right? Sometimes you may see that for a small size data, you may get extremes, right? But any type of extreme, either values getting misclassified or something of that nature, you should double check. So that's why I was going line by line to see where exactly something might be wrong. So it was more in the hyperparameter setting.
And sir, this is a group assignment, right?
It's a group assignment, but I think it's very, very trivial. But yeah, you can, more details will be helpful, right? I mean, what you've learned from this, because model fitting is a very, very straightforward thing. So the group assignment is fine, but the weightage of the marks will be more on your commentary and what you've learned from it.
Okay, yeah, got it.
Sir, do you expect to do us the hyperparameter tuning on both DT and random forest?
Yes, I think that'll be good.
Okay. So basically 4 models.
Yep.
One without any tuning, plain vanilla, and second one with hyperparameter tunings.
That's correct. That's correct. But you can do all of this later on. So I'm saying, I mean, as long as you're comfortable, you can do it. I want to now move on to the fitting of many models using H2O. So
Okay.
shall I do that?
Yes, please.
You
I was
can,
just
you can
asking
make
about
the,
what to submit.
huh?
I just wanted to know what exactly to submit.
Correct. Yeah.
Yeah.
Okay. So what do we make out of the H2O? Anyone has done the reading? What do you think this is?
It is kind of auto ML tool where we can put the data and it will apply multiple algorithms and with like all the good hyperparameters. And then it will
That's
give
correct.
the leaderboard. So like this
That's correct.
particular algorithm is performing best, and then we can get the parameter and we can go ahead with the first, like the best one algorithm, or I mean, that is the main idea of H2O.
Yeah. Absolutely. So you can see H2O is like one of the very popular tools out there. And they have many different products, right? So they have free package that we're going to use in Python, but they have driverless AI. For example, anyone who wants to have a low touch modeling, they can do that using H2O.ai, right? There are many other tools. I mean, I'm not going to go through all of them. And if you read my blog, I have spoken about one Windows-based tool where you can do the point and click and you can build the model. I don't know whether I'm going to have time to show you that capability, but you can definitely follow article number 51, which will help you set up that point and click. So you can drop that this is what my dependent variable is, these what my independent variables are, and then you can build the model, right? So that is there. So this is how you can set it up. But what I'm going to do the demo on today is the H2O package, which is an inbuilt package within Python. Acha, screen sharing. Okay. So this is what we're going to do a demo on. So there is a package called H2O within the Python library, and that will help you do a lot of these, classification regressions much more easily. So I'm going to walk you through how we do it. So if you are in Jupyter Notebook, you'll have to do some research. I think you can still make it work there. So you may have to type, let's say, conda install H2O. Let's see if this works. So if you're in Jupyter Notebook, definitely install the conda. Definitely install the H2O using the conda prompt. And you may just research a little bit on the Google. I think, I mean, this should work. I'm just gonna copy paste, see whether you are able to use that in the Jupyter environment. Otherwise, in the Google Colab, you are more or less plug and play. So try it out, people who are there. Just make sure that you're first able to get installed. And how would you know whether it's working? So for example, if I do pip install in the Jupyter Colab environment, it will take some time. And then you'll get this confirmation message, which is going to pop up anytime now. So this will speedify some of your modeling approaches, right? And you don't have to try one at a time. You can actually try many different models simultaneously, right? And see what is the best model that you're getting. Okay, so you can see the installation is successful. The other way to confirm whether the installation is successful or not is just say import H2O. And if you have been able to successfully import, then it should be fine. Otherwise, you'll get some error message. So I'll wait for you to confirm whether you are with me till this stage, that you have installed the H2O, you are able to import the H2O. For both people who are the Collab as well as the Jupyter notebook, Collab will be easier, but Jupyter will take maybe slightly more time. But I would require a confirmation before I move on. Okay. So just do research on some other command. Let's see if you're able to install, or maybe you have to go to the H2O library itself, right? Not the Anaconda, but you can say conda install H2O Python, right? They might be in H2O documentation itself, they would have spoken about how to install it. Like, let's see. Yeah. So this one, for example, you can see, which is from the H2O docs itself. Oh, this is a downloadable version. Don't worry about that. So I think that's the one I have already documented on my blog. Install in Python. So these are some of the dependencies. Try to install them and see whether that works. I'll put this link and you may want to explore that as well. See, they are saying, I mean, go ahead and install this version of Python. H2O in Python, basically. Or you can use this conda install as well, but they are specifying a particular version. So maybe there are some version dependencies. Try it out, different things. Let's see which one works.
Working in Colab, sir.
Collab is working, yeah. Collab is easier, but we'll wait for others to confirm in Jupyter as well. Otherwise, you can do it later.
Yeah.
You can now move over to Collab and you can do it later.
It's working for me.
In the Jupyter or Collab?
Jupyter.
Okay. Do you want to put that command so that others can also follow? How did you install that?
It just did a pip install, that's it.
Oh, you just did the pip install. Okay. Straightforward. Let's see if that works.
Yes. All for me.
Amit, you want to try it? Pip install. Working now? Okay. So it's working for most of us, right? So then let's forward. And we're gonna use AutoML library within that. So from h2o.automl, I'll just zoom in a little bit. From h2o.automl, we're gonna import the AutoML package, which basically will do all the modelings for you, right? And now we're gonna, just like we were using the Google cloud earlier on, we're gonna now use the H2O cloud. You're not able to get there? Yeah. Acha. Valsa will be there as a live assistant in home as well to help you figure it out. Huh? Huh? Are we good, folks? Everyone? And then this I will just put there in the chat window so you can copy paste because it's a long code. So you can just put it there. Basically, we are importing the data. This first line is not necessarily required because we're directly putting the URL one more time over here. So you can ignore the first line. So what we're saying is like once you've done the auto ML, we want to initialize the H2O instance. And that's what basically the INIT means, that I want to create an instant in the cloud, H2O cloud, for creating this instance. Right? So we initialize that instance. And once we've initialized that instance, then we will import this data, which is another wine data. But this is going to be a regression problem that we will be building.
So what we are predicting here on this data set?
I will show you. Once you import the data, I'll let you know. But please confirm whether you are, sorry, go ahead. Done?
Yeah.
So just a recap, we installed the H2O, we imported H2O, we imported H2O ML, auto ML, then we initialized the instance. Then we are importing this file, which is saved on the S3, Amazon AWS S3 buckets, right? Or basically the storage. And we are reading directly the file from there, right? And we will see what really happens next, right? So even before we go to that, you can see it's generating bunch of this summary for you, right? So it will check whether you're already using any H2O instances. If not found, then it will start a new instance for you on the H2O server. It will give you some other details in terms of the runtime environment and what is loaded and not loaded and so on and so forth. And then it will say that your server is running and which version you are on, how much is the free memory that is available there, right? And so on and so forth. And then you are good to go. And then what this is showing you in the end is basically the file that you've loaded, whether the file has been read correctly or not. And then what we're going to do next is describe, df.describe. And these are H2O data frames. These are not Python data frames. So there is certain differences that you will see because now we are completely in the H2O environment, right? So they're not same as Pandas data frame. So when we do this, we have created a data frame, but after parsing and all of that, you will see it will become different. You can see already it's stating out certain things differently, like sigma and so on and so forth, right? Some of those differences will automatically jump out to you. And it gives you the top 10 rows description with the layout as well, along with the other summary, right? So everyone has the describe working?
Yes, sir.
Okay.
Yeah, working.
Yeah, all good.
For me,
So,
still waiting to initialize H2 on my local.
oh, it's waiting for you. Okay, let's just give it some time then.
So it says starting a cluster.
Yeah.
And
Just give it time. It should. Oh, it failed. Okay, then just do the step one more time, like the initialization one time. For people who are running in the Jupyter notebook, are you able to initialize, Amit? Yeah, working for you? Okay. So in your case, something may have happened. Just run one more time, actually. Others are able to get it, even in the Jupyter environment.
No, sir, it's failed again.
Okay, you want to share your screen?
Yes.
Go ahead.
So I installed H2O here. Pip install H2O.
So go up to the very beginning. Go up to the very beginning.
Yeah.
Okay, so you're doing pip install. Yeah, come down. I saw some red there actually. Come down. Pip install in the same line 104. Yeah, hold on there. You should consider upgrading via this pip install upgrade. So
It
why
is
don't
for
you
my,
just do the upgrade?
no, it is the upgrade of my pip command. Okay, I will do that.
Okay, so you're saying this is not required for you?
No, this is pip command. I will do it.
No, this is upgrade for your this one H2O, not the upgrade for pip. Or is it giving you the warning about the pip?
This is the upgrade for pip. Upgrade pip.
Acha. Okay, then leave it alone. Then it's okay. Then leave it alone. Don't do it. Then do the import H2O.
Yeah, I did that. And then I printed the version of it.
No, just run it one more time. Run it one more time.
Yes. Yes.
No, the line number is not changing for you. Are you running?
Yes, I run it.
Yeah,
Okay.
okay. So there was some delay. No, hold on. There was some delay. So it wasn't refreshing on my side. That's fine. 116 is there. H2O initialize. Yeah, run that one now.
Oh, excuse me, sir.
Yeah.
Sir, I think so. We should install JRE, latest version of JRE. Then,
Latest version of Java.
yeah, Java runtime environment we should install. I think so. Then this will work. H2O topic. Yeah, the
Yeah,
same as
let's look
even
at the
I
error. So Sri Valsa and Chirag, they are saying that it's because of the Java not being updated, right?
Yes, sir.
Go down. Go down. Where exactly you saw some error, Sri Valsa? Last. Acha. Let's go down to the very last. The very last. Yeah. Cannot find Java. Please install latest Java. Okay, yeah. So I think you don't have the Java actually. Do you, Krishna?
I have, but it's on my. Okay, so I'm running this in my virtual environment.
So that's where it's actually not installed. So you'll have to install the Java in that virtual environment.
Okay, then sir, it will take some time. Please proceed. I will fix it.
So you can use the collab in the meantime, Krishna.
Okay.
So what is happening is Java is what it is using to connect to the cloud. So that's why it's not able to fire. Thank you, Srivalsa and Chirag, for pointing out. So that is the error. And that's why you're not able to get it. So let me share my screen. And in the meantime, you can, Krishna, do the same thing in the collab, just to keep pace with everyone else, yeah? All right, so once you do the df describe, you can see that this is how it looks like. This is where it's gonna be slightly different. So I'm giving you an end-to-end walkthrough of how we do a model in H2O. So here, when you look at this data, you can see I have, I'm too much zoomed in actually. So here you can see I have something called as, where is it? Acidity, this. I have quality, right? So quality is basically the type of wine that we have. So you can see that I have quality, and this is an integer, right? And this is what the dependent variable in this data is, quality of the wine. And this we are predicting as a normal regression problem, because you can see this is, taking a many different values. So people have rated from 1 to 10, and we're going to do a regression problem on this. So that's what the quality variable is. So we say my Y is nothing but quality. And then what we're going to do is that data frame that we have, we're going to split that data frame into 80 and 20. 80 will be training and 20 will be your validation or the test data. And your train is the first split, test is the second split. So slightly different than Python, but easy to figure out, right? I'll wait for you to confirm whether you are up to speed on this. So all we have to do is to say which one is your Y variable, which is quality of the wine, which is the 1 to 10 scale that you're looking at. So you can see over here, it says 1 to 9, in fact, I think. The min is for this 3, not even 1, it's 3. And the max is 9. So 3 to 9 rating is what wine has. And we're going to do that prediction.
And why do you use the seed as a 1?
Hmm?
The seed is equal to 1. What is that?
Seed is just for your splitting the same way. If you want to rerun the code again, same observations will be there in the train and test. You can have any seed. It's like a randomization thing that we've talked about earlier on in the Python algorithms. Here they call it seed. Like a random seed, you are just looking at a seed. It's the same thing, no difference at all.
Got it, sir. Thank you.
Yeah. And what we're doing is we're doing 80-20 split. You can do 70-30, you can do something else, whatever you like. I mean, that is fine. And the first split, which is 80%, will be your training data. The 20% split here will be your test data. So I'll wait for you to confirm whether you're up to the speed.
Done, sir.
Okay. Folks over here, Nish, Amit.
Done from my side.
Okay. So you can again do the train describe and test describe just to really make sure that it is for the intended one, right? And you can see I have 5205 observation in the train and 1292 in the test. And the original one was a summation of these two. So the data has been split into two, right? So that's all we are doing, nothing else, right? So just do a train describe, test describe, make sure that the numbers add up before you move on. Again, I'll wait for you to confirm. Previous line, okay. This one?
Yeah, good, sir.
All right. We'll wait for a couple of minutes for the people who are catching up. Are you good, Pranish? Type.
So the describe function looks very different than the regular
Yeah, it
describe
is.
this time.
Yeah, it is the H2O describe, not the Python describe. That's why.
Okay.
So they both work similarly, but slight differences.
Got it. Okay.
Yeah. Awesome. These are like fractions. Again, this is slightly different from Python. So the fractions are represented as real, and you can see some of the other ones, like the quality is int, right? But we are positioning that as a regression problem. So we'll see that getting converted into the this as well, right? And then we have a type, which is the enum, which is the white wine, white. Everything is white basically, right? So that problem that is not necessarily needed for us, right? Huh? Done? Okay, so then here is what we are going to do. So you can see this is all my ML code is. This is all you have to type. So it will make you lazy also, but the interpretation is gonna be the real key. So what we are doing is we are creating an object called as AML, and that is H2O auto ML. Max runtime is 60 seconds. I just want to give it 60 seconds. I don't want to give it like too much time. If you want to really build a very sophisticated model, you can give it more time to run. But it may also be stopped if you're using too much of their server. So I'm just gonna use it for 60 seconds. And again, seed is 1, or you can have any seed you want to do. It doesn't matter. And then I'm doing AML.train. Slight difference in terms of how this works. So you have to pass on what is your Y. Y is nothing but the Y that we have defined over there, right? So we have said Y is nothing but quality, right? So Y is quality. So you have to say my dependent variable is quality, and training frame is the train data that we have that we have created. Now you can see it's gonna fit many different versions of the model very quickly.
But here for the X data frame, we are not excluding Y.
Say it again.
To get the X data frame, we are not excluding dependent variable.
No,
in
no, we're
H2O.
not. That's why I'm saying it's, yeah, it works slightly different from the Python. So we're not doing the X and train, X and Y separation and all of that. We just have to tell that within this training data, my dependent variable is called Y, and Y is nothing but the quality. So it will automatically be able to separate it out and do that, all the things that we have been doing by hand in Python. Hmm? Which one? Zoom, acha.
Okay, done, sir.
Is that fine? So this is where we are training the model. So max runtime, 60 seconds, H2 auto ML, training, Y is equal to Y, which is nothing but quality. Training frame is nothing but my training data that we have created. Are we good? Have you typed? Then you can run it. If you've typed already, you can run it. Then it will start to generate some summary like this for you. And it may not be able to fit all the models for you because of the time limitations that we have, but you will see that variety of different models will be fitted, right? So you can see for each model, it is giving you different summary and all of that. And it will do a cross validation matrix summary for you as well, right? So it has done already a 5-fold cross validation. Sorry, not 5-fold cross validation. We'll have to see how many folds it has done. 1, 2, 3. I need to zoom out to see 100%. Yeah, it has done 5-fold cross validation for you by design. And there are parameters that you can change within H2O. I'm not even going there. For the 5-fold cross validation, the mean absolute error that you're getting for the best performing model is 0.46. For the best performing model is 0.46, right? But we'll see what that best performing model is and other details around it, right? So everyone has this table now? Yeah.
Yeah.
Yeah, done.
This is where, sorry, go ahead.
Just go back, sir.
The code. This one.
It is generated, but somehow this table is not there.
Table is not there. Okay. Can you try to rerun it one more time? AML.train, why training frame is trained. Let's see.
Just scroll down.
So can you please scroll a bit on top of
Which one? Here?
little tops a second. Yeah, after that. Okay. Got it. Train.describe. Okay.
The most important part is coming now in terms of interpreting the model, which is where the leaderboard is generated, right? So you can say AML dot explain on test data. So I'm not doing this on the train data now. I'm saying on the test data, EXA, which is basically just short for explain, right? I want to generate the leaderboard, right? And that's where basically it will show you all the models it has fitted for you, right? It says I have fitted a stacked ensemble model, best of family, stacked ensemble model, 2 AutoML model, basically 3 AutoML models and stacked on top of each other. Then it has done for 2, then it has done for 1, and many different versions. I mean, that's why it's a black box. So if you ask me what exactly went on in this particular model, I wouldn't be able to tell you. And that's why they are called the black box. They just explain things, but we don't know how and what it has fitted. That's the machine coming in. So, but the bottom line is the best model, which is the stacked ensemble model, gives you the root mean square of 0.62, mean absolute error of 0.46. Right? And it has fitted many other models. Let's see how many you can recognize. What is GBM? Anyone? You heard about that a little bit earlier today.
Gradient boost.
It's an ensemble model.
Yeah, correct. Gradient boosting machine. So one setting of gradient boosting machine, another setting of gradient boosting machine, which is a boosting algorithm, right? DRF, what is that? Distributed random forest, which is a bagging algorithm, right? So stacked is basically a combination of the bagging and the boosting. These are the boosting models. This is a bagging model. Again GBM. Then you have 2 more boosting models, right? Again, you have 1 more GBM. What is GLM? Generalized linear models. They're like the linear regression, logistic regression sort of thing, right? So GLM is also one thing that they are trying. XGBoost and deep learning also. I don't know, I mean, how much time it took to really fit a deep learning model, but they did fit a deep learning model as well. And then we have an XRT, extreme randomized tree, right? So again, they are like the form of the bagging algorithms. And then you have another boosting algorithm, right? And then you look into the fitted versus the residual. Residuals should not show any pattern if the model is good and so on and so forth. And then this is the variable importance, right? And which model this is showing the variable importance? For the best performing model, which is the GBM4 AutoML1. Let's see whether that is the best performing model. GBM4 AutoML. Oh, okay, because the interpretation will not be possible for the others. That's why it's actually showing for this one, which is the lowest among the non-stacked models. For stacked models, it's not able to generate that summary for us. This is always in the descending order. So you can see the best performing model will be on the top and then you come down, right? But for the feature importance, it is not able to show me the stacked because stacks are models on top of the models. So you have to go to the next non-stacked model, which is the GBM4 AutoML model. And that's where it is showing you the variable importance, right? So alcohol plays the highest role in the rating of the wine, right? So naturally, I mean, if it is more alcohol content, people like that wine. I mean, generally speaking, right? Huh?
One question.
Yeah. Sorry,
sir,
just one. Go ahead.
Sir, actually, we are doing quality analysis. That's why it is a regression problem, and that's why all the models that it is showing are all regression models, right?
Correct.
Yeah, so it can do this classification also. It can do no.
You can do the
decision tree.
classification. Yeah, you can do the classification, but then you have to do the typecasting of this variable. I'll show you the quality variable that we had. Same problem, you can do a classification. But you have to convert the quality type from integer to enum. So enum is a discrete variable. Otherwise, it will be considered as a continuous variable. I'll show you the classification in a minute as well in a different data set.
Okay.
Variable importance heat map. Yeah, but let's go step by step, right? So let's go leaderboard. So leaderboard is clear, right? Different error terms and all of those things that you're having. And that's what you're actually looking at. Residual is nothing but your actual values versus the fitted values, and it should not show anything. Variable importance is where you get to understand which variables came out on the top in this gradient boosting machine model. And this is basically nothing but like, you know, timestamp and what model you have fitted and all of that, just a model nomenclature. Alcohol, first most important variable, volatile acidity, sulfur dioxide density, chlorides, and so on and so forth are the other important variables. Yeah, you had a question, Amit? Heat map, yeah. There are a lot of things that you should not necessarily worry about, but it's basically telling you by different versions of the model that you've built. So you have the different variety of the models that this has built, right? Am I finding the same variable which is important everywhere? So for example, this is the high scale, this is the low scale, color coding. So it says XG boost grid one model one, whatever that model was, density came out to be the most important variable, right? But let's look at the alcohol, right? So alcohol, for example, came out as the most important variable over here. And then GBM4 also we had. And you can see GBM4, this is a relative importance. So like, I mean, whether all the models were tying out on the same variables as the important, or they were having some diversion. Correct, from the best performing model. Correct, that's correct. Yeah. Huh? Is red for you? So this may not be refreshed on my screen. So let me just rerun all of that. So that may be another thing that I don't think I have run all of that. So let me just do it one more time. That could be because I haven't refreshed some of the things. And every time you run, you will get a slightly different version of the model. So that's completely understood. We'll take a look. Let me just refresh that.
Sir,
So I'll just,
focus.
Yeah, sorry, go ahead.
Yeah. I was asking focus on or highlight some
Say
area
it
like
again.
why. Yeah. My question is highlight some area why H2 or the AutoML, which area it will not be suitable or it will not be ideal. Like otherwise everyone will go for AutoML, right?
Yeah, what do you think could be the answer? What do you think?
Answer, I really don't know. I mean, the way it
Anyone in
is
the
showing,
class?
I think
Why would
AML
H?
can be used,
Yeah.
whichever the best model which we can use. And based on this recommendation, we can choose, the best performing model.
Right. So the way, I mean, there is nothing that is stopping you from not using this in like everyday life, or don't even look into the other ones, right? But what is more important is, can you really make sense of what you're looking at, right? And what people use AutoML in the industry is just to really figure out what is the best performance that we can accomplish, right? From the given data that we have, from the different modeling techniques that we're looking, what is the best performance we can glean from it? And then they will do their own separate model development, leveraging some of the like findings from over here. But very few people will generally go with the AutoML completely, because it's just like, you know, you don't even know what has happened. right? And how would you explain it to the stakeholders, and all of those problems are there. So that's the main challenge, but it tells you like, what is the best possible performance that I can get from the model, and then use that to sort of like, say whether I'm in the territory or not. So for example, I got the MAE of, let's say, whatever that value was. Now I have got the best MAE as 0.46. Now, next time when I'm running it, any other model, I know at least what is the best possible performance that we can expect. So that's how we use it typically, right? Now you can see, because my data was not refreshed, now you have the agreement coming in, right? So all of them are sort of peaking for the alcohol content. I think there was some problem that I may have run the previous version or whatever, right? And then you can ignore some of this, which talks about whether I have the models correlating to each other and all of that. Variable importance, you can look into it later on. This is important in my view, right? And let's see if anyone who would like to explain me what this may mean. This is very important chart actually, which is the partial dependence plots. Partial dependence plots. Any idea what this may mean? So which one is our best model? This is our best model. GBM4 is the best model, which is in the dark brown color. Yeah, go ahead. Anyone who would like to explain?
It is actually this particular graph is showing the change in the mean mean response. Now,
Yeah. Okay. I will. Yeah. Amit, you want to take a step?
This is like they compare.
Uh-huh. Uh-huh. Right. Yeah. So the partial dependence is basically the direction. So you can read from over here, right? And you can always do more research on it. Basically, it says your dependent variable, how is it related to alcohol while holding everything else constant? While holding everything else constant, if I change my alcohol content from 10% to 11%, what is going to happen in my rating? So if I read from the GBM4, and hard to know which line is which, I mean, but you can change some of the colors later on. But I think GBM4 is this line over here, this line, which is non-linear, right? So if I change from 10 to 11, based on the GBM4 model, my rating will go from, let's say, 5.6 something to over here, which is going to be 5.9 something. So that is what basically the influence of the alcohol will be if I change that, right? And you'll see there are many other charts. Like if I look at the yellow one is GLM. Is there any wonder why this line is a straight line? Because they are the generalized linear model. So that's what's drawing a straight line. So they're saying that alcohol and the rating, they have a linear relationship. So that's where it is fitting. But we can see that the best models is, no, it's not linear. So there are step functions and all of that, right? So for example, if your alcohol is too low, you don't get any good rating. But from over here all, you can see that suddenly, and also if the alcohol content goes too high, then the law of diminishing return kicks in, that you don't get any extra boost in the rating and all of that, right? So that's where it's the non-linearity coming in. But alcohol goes higher, generally speaking, your rating goes higher of the wine. How about this relationship, acidity versus the mean response? What happens if I make the wine more acidic? People don't like it, right? They don't like the more acidity and all of that, right? So you can see generally the trend is linear, but again, it flattens out. So beyond a certain point and all of that. This is another one, which is very interesting. Free sulfur dioxide, free sulfur dioxide. So it has more like a parabolic relation, right? Or I mean, I don't know why that might be the reason, but you can see some relationship coming in. You have another one, which is the density, which is a flat line, almost no effect at all, like how dense the wine is, right? Chlorides, I don't know too much to read from it. And then so on and so forth, right? Some of these charts I myself will have to investigate more. in terms of the what they really mean, and you don't have to worry about it, but something that you can play with, right? In the next 5 minutes, I'll just quickly show you a classification problem, and I'll share that code with you as well. And then, sorry, then you can make the prediction on the any unknown data. So it's just using the predict, you can make the prediction, and then you'll be able to get your prediction from it, right? Yeah, so this one is a prostate cancer data, and I'll just share this file with you. Folks, you can do it later on. I don't think we should do it end to end over here. You can definitely do later, but I'll just run through the same workflow. So this is a prostate cancer data. I just shared the file location.
Sir, one quick question, sir.
Sorry?
Sorry to interrupt.
Go ahead.
This PDP chart is very important. So what is it is saying, as you said, partial dependence on alcohol, suppose. So changing in the alcohol dependence plot for alcohol with respect to mean response of what quality. Here mean response, these values are coming based from quality.
The rating of the quality, right? So
Quality.
the quality column, yeah, that's correct. So this is quality rating. This is the actual independent variables that we're looking at.
Okay.
All right, so I was going to show you the prostate cancer one. Let me see if I can quickly show you that, a classification model. So you can see how we can change the, some of the variables to factors. So after you change it to the factor, then you can move on. And again, you can read more from the H2O library, but I'll just show you one of the examples. And we are looking at response column as capsule, whether they are taking the capsule or not. You can see the predicted probabilities coming in. And then we are looking at the same sort of output. But over here, you can see now the confusion matrix has been generated, right? And you will get more. I think I'm just fitting a GLM model over here, but I can do the AutoML as well. But I just did a generalized linear model for the sort of like a logistic regression for this data, but easily doable, right? And let me see if I have an AutoML as well. So I am doing for this, but it's taking longer time because I'm just hitting their server. But over here also, yeah, I don't have the output, but probably in the next class, I can show you something on this where I'm doing the AutoML for the classification problem as well. You can run it on any other data as well as a homework, right, that you want to try on. It's taking much longer than expected. That's why actually it's running. So I have maxed out the time to 1 hour, so it might take some time to get the output, but this is the AutoML on the classification. I'll take a pause over here and see if there's any last questions before we wrap up for the day from anyone. I hope you got a good view of, how the AutoML really works. And there are many, many AutoML algorithms out there. Like Amazon has something, right? There's something called as Google AutoML, right? And there is Azure ML, right? So everybody has AutoML packages that you can actually tap into. But not recommended for day-to-day working because you cannot really tell. Like if you go and present the AutoML model to your stakeholders and they ask you a couple of questions, you will not even know what exactly it is. Imagine that if you did not know what is a boosting, what is a bagging, what is the stacking, and then suddenly you are looking at these many models output, it becomes very, very difficult for you to interpret, right? So this is more for the people who are pro and who want to really understand whether I'm doing the best in terms of my model or not, just more for the benchmarking. Folks online, any questions from anyone?
Sir, you will share today's Jupyter notebooks with in the LMS, right, sir? In case we miss anything.
Yes, sir. I think I also have the same request actually. I was just chatting with Vijay.
Yes, sir. The H2 one and the decision tree one.
Sorry, say it again. I couldn't hear very well on this TV. Just a second. I'll just put it on the headphone. Yeah, sorry. Was there a question? I missed out. Can you say it again? Chirag?
Yes, sir. So, few participants they need Jupyter notebook for today's session. H2 and random forest and decision tree.
The random forest and decision tree and H2O. So I believe everybody has typed it in, right? But I'll be happy to share or walk you through. I'll have to just take out the unnecessary section and then I'll share that.
Thank you, sir.
Okay, sir. Thank you.
Okay. Fair enough. Yeah, because the voice echoes too much on the TV and I'm standing right next to it, so I cannot hear very well. Any other questions, folks, online before we wrap up? I want to give you the reading assignments for next time. I know, we are slightly over-indexed on the last class, so how much we can accomplish, we'll have to see. But they're all easy topics, so I think we can definitely squeeze in. So I'm just gonna give you those 3 links that you should go through. The first one is gonna be article number 41. And I'm just putting the link, and Chirag, if you can make a note and share with others, that will be helpful.
Yes, sir.
Right. So the first one is sorry, I don't think I copy pasted the link correctly. The first one is going to be the market basket analysis. Very, very easy topic, yet very, very important. So that one. The PCA continues to be pending. So we'll spend time talking about that, which is the article number. Let me search. 39. And then the last one that we're going to do is clustering. So these 3 topics are pending. And then we'll talk about that. So the last one is clustering, and we will look at k-means particularly. There you are, right? So these are the 3 articles that we should try to read through and come prepared for it. All right. Any final questions, thoughts, people, before we wrap up? I can cover PC right now, but I don't think you will get the entire concept. I think you need to be fresh a little bit for it. So that's what we're going to do next time. And these are all not as complex topics as what we've done earlier on. So I think that should be easy to digest. Folks in the class, any questions, thoughts from anyone? All good? Yeah. Okay, that's it then. Thank you, everyone. Have a good weekend. Bye.
Bye, sir. Have a
Thanks,
good evening.
everyone. Bye.
Thank you, sir.